Introducing Phinnius, the flying pooping pig. Not only does Phinnius have the remarkable ability of flying, but he also has an amazing talent to leave a poop behind exactly once per second, or 1 hertz. This is known as frequency. Let's check out Phinnius and his remarkable talents when he flies at constant velocity. So of course, every second that goes by, he drops a single poop, just like this. So what we can do is track his motion based on the trail that he leaves. So here we go. We have a velocity versus time graph, meters per second and seconds. And if Phinnius moves at a constant velocity of say 2 meters per second, that means that every second that goes by, he'll have moved 2 meters forward, 2 meters forward, 2 meters forward. Recall that the area bounded by the velocity versus time graph gives us the displacement relative to the previous position. Okay, so on a position versus time graph, it looks like this. We've seen this before. So we have at time equals 1, position equals 2. Time equals 2, position equals 4. Time equals 3, position 6, and time equals 4, position 8. Very easy to read. So let's look at the poop trail that Phinnius left behind. So this is just a stretch of displacement. Here we have the origin over here. This is x in meters. And so we see that he's going to leave a poop at position 2 after 1 second. Position 4, position 6, and position 8. It's a little green because he probably had a little bit of hay or something like that mixed into his food. He's quite fine, don't worry. Constant velocity patterns show the same magnitude displacement at each time interval. So it's constant because we have 2, 2, 2, and 2. The spacing is the same each time. What's more interesting is when we check out Phinnius flying with something known as acceleration, a change in velocity. Whoa. So let's take a look at Phinnius when he moves at a changing velocity. In this case, Phinnius starts from rest, which means that his initial velocity, or V naught we would call it, is 0. And uniformly increases. And the word uniformly is kind of key. It means that he's going to increase his velocity equally after every second. And that'll become apparent when we see the velocity versus time graph. So his velocity will uniformly increase 1 meter per second every second. So that's 1 meter per second. And so the division sign here means per, by the way, division means per. And so 1 meter per second is the same thing. We can write it as 1 meter per second squared. It's often referred to and written this way as shorthand, but this is better in terms of the meaning. So it means that every second that goes by, we're increasing our velocity by 1 meter per second. All right. So what we have here is a velocity versus time that looks a little bit different from the one before. Don't panic. We'll handle it. We're going to use the same rules as before though. Every second that goes by, 1, 2, 3, 4, we can determine the displacement relative to previous position by finding the area bounded by the velocity versus time graph. So here we've got this shape, it's called a triangle. And if we take this area here, it's 1/2 base times height. So 1 times 1 times 1/2. And the area of this triangle is 1/2. So from 0 to 1 seconds, Phinnius would move 1/2 a meter. In the next interval of time, from 1 to 2 seconds, he increases his velocity from 1 to 2 meters per second. You see what uniform means is that this is going to be a straight slope velocity here. We'll learn that this slope is actually acceleration. That's going to be one of the next things we develop from this. And what we have here is an area that is this, I guess it's called the trapezoid, but we can break that down into this square and this triangle. Well, the square is 1 times 1 in base times height, and this is 1/2. So this is 1.5 meters of displacement relative to the previous position. So he'll have gone a total of, well, 1/2 plus 1/2 plus 1. That would be 2 meters. And so on and so forth. From 2 to 3 seconds, it's 1, 2.5, meters in terms of additional displacement, and then 3.5 from 3 to 4 seconds. So he increases this gap, and you'll see what it looks like on the PooP trail, okay? So here is the position versus time graph, and we'll go to the PooP trail. Easy now. I was kind of anxious to get to it because it's kind of exciting, but in the position versus time graph, we see that the position is 1/2, then 2, then 4.5, then 8. Notice that this creates a curve, an upward curve, and that upward curve means that the slope must be changing on a position versus time graph because the slope indicates the velocity. So the slope is here, and then here, and then here, and here. It's getting steeper and steeper because the velocity is increasing, getting higher and higher. So we're seeing that here. That's why this is a curved pattern, and it's really important to notice that. And so on the PooP trail here, we have a pattern that looks like this: 0, 1/2, 2, 4.5, and 8. So interestingly, he will be at the same position after 4 seconds as when he went at constant velocity at 2 meters per second. But then he's going to just increase and exponentially get ahead of the constant velocity. So acceleration patterns show a change in magnitude of displacement each time interval. What that means is that each time interval that goes by, we have an increase from like 1/2 to 1.5, 2.5, 3.5, and that is characteristic of an acceleration, that all of these intervals have a changing displacement. And so that's what it is. All right, so hey, Phinnius and I would like to say that's what it is. All right, Morad and Phinnius out.